Normally I record these videos with a lot more editing and like buzzes and whistles, and the audio is a lot better. But my schedule this week is so busy that it's going to be really hard for me to update it, like do the quality that I want. So these are going to be very basic videos. So just next time they'll be better. Anyways, so we're going to take a test on Friday. Let's get started. This first batch, you'll notice that this is kind of textbook type questions, and these guys are kind of more skeleton, more structure. A lot of these over here will be multiple choice, and this is a total overkill. All right, it's just really good practice until we take the test on Friday. So I'll go through them. Hopefully I can get this first page done at least for you today, and then they'll trickle in so that by Thursday class time you should have them all. All right. Okay, so here we go. The range. Now you'll notice that this particular graph, it's got some holes in it, and I gotta watch out for holes because that means that there's an element that is actually not included in my domain. All right, you gotta watch out for that, and it can be part of your. It can be an issue in your range as well. Now what I did is I just solidified that dot right there and put made it, because it just went up to it, but because of the lack of a hole or lack of a circle, then I'm going to make that a closed dot. Okay? It'll be more clear when you take your test. All right? So let's look at the range. Now, the range is mentioned first, so let's do that. We go from the lowest to the highest. And as I go from the lowest, I do know that I am including -4. It's kind of hard to see. Maybe I should use a pen here. Let's grab a pen. Okay, we'll grab a pen. All right, so we're going to go from -4. All right, and the range, let's zoom in a little bit there, and the range is going to go all the way up to the highest. Now what this represents here is we're going up to 2, but we're not going to include 2. We're like going to like 1.9999999. You know, we're going real close to it, but we will not include it. So don't touch the fence, but go up to the fence, okay? The domain, our orientation has to switch from left to right, so I look over here to the left, and I see that I am including 5, but as I move across, I am not allowed to have a -3 value. You'll see that there's a hole there. So, unfortunately, and this throws a lot of people off though, but that hole represents you can't have it in your domain. So we're going to go up to -3. Okay, now remember, these are the x coordinates as I'm moving across. Okay. I have to close it up with an open circle because I go up to -3. Then I have to start again on the other side from -3. Okay, so on this side of -3, I'm going to go all the way across. We're good, we're good, we're good, we're good, all the way until 4. And then I will stop. But it's an open circle, so I will not include it. So that is the domain. It's in 2 pieces. There are 2 pieces that are pushed right up against each other, right up to that point, but there's 2 pieces here, okay? This guy, he's at the end, so we're not, there's not a third piece over on the right-hand side. Okay, so watch out for that. These can be pretty tricky. What intervals where the graph is positive. So what I'm looking for is I'm looking to cut this graph in half. There's pieces that are up above and then pieces that are below. I notice that this part right here is above, and so is that. Everything else is below. Okay, so the positive interval is going to go from -5 up to -3. Can't include him though; he's outside of my domain. And then it's going to go from -3 to -2. Okay, so just that little piece. Then 1, 2. Here's the third piece. I'm going from 2 all the way to 4. And notice that I'm not including any of them. I can't include 2 because he is actually 0 right there. But as soon as I step off of the 0, just as soon as I step off a +2, for a moment he'll become positive. But I'm not going to include 2 because he is 0. Now the x-intercepts, okay, those are the spots where I actually hit the x-axis. Okay, the x-axis is hit at -5, 0, comma. Notice I'm not using a u though. Okay, this means I'm dealing with points. Okay, there we go. I didn't realize it was out of focus. I'm dealing with points, not intervals. Okay, the u implies that it's intervals. Because these guys look like points, but when I put a U, that means I've got windows, okay, intervals. All right, so x-intercepts. Then I've got -2. Ow, ow, ouch. Just pinched the hair on my arm on my desk. Ouch. And then I've got a +2. All right. So if you would have just listed them as x equals -5, -2, and 2, that's also acceptable. Okay. Just make sure you put an x equals. So either way is absolutely acceptable. The average rate of change from 0 to 2. Now the average rate of change from 0 to 2 just represents the slope between the 2 points. Now on my domain on this function, here is 0, -4. Okay, so from 0 right here to 2, I want to know from 0 to 2 what is the average rate of change, and that is the rise over run between these 2 points. Okay, you'll notice that it is 4. You're going up 4, and we're going over 2. Okay, so that is an average rate of change of, 4/2, which is 2. Okay. All right. Next, find the sum of this right here. So let's see. What I want to find the sum, I'm going to need this formula right here. Okay. The problem is that I need an n, I need an a sub 1, I need my last term, and then I need to divide all that by 2. That's how I do the sum. Okay. You could use sigma notation. It's a little trickier. I would recommend going with this. Sigma notation only do like when you actually have sigma notation. Like for example here, just do sigma notation like that. Otherwise, for this, you're going to have to develop a rule. You can, but that's kind of more of like a pre-calc topic. All right, so I see that my first term is 22 and my last term is -77. So I do have, this guy's going to be 22, that's -77, but I don't know how many terms are in between here. Okay, so what I got to do is I have to figure out what my n is. Like how far did I go? Okay, now I'm using the a sub n formula that looks like this. Okay, what is the n value? How far did I go to get to -77? Okay, you got to be really careful. Because remember, you have to count. You could just list all those and count how many there are, but I'm going to use the formula just in case it's trickier on the test. Now notice I'm going down by 11 every single time, so this means that my d is actually -11, and I don't know what my n is. So I'm going to have to solve for n in just a second. So I'm going to subtract that. That's -99, okay, equals -11. Okay, then I'm going to divide by -11, so n. So n minus 1 equals 9. And looks like n would have to be 10. Okay, so this means I'm going 10 terms up here to get to -77. Okay, 1, 2, 3, then 4, 5, 6, 7, 8, 9, then 10. Okay, and again, you could have wrote these out. All right, now I'm ready to use my formula because I'm going to use s is 10. Okay, and then I go 22 plus a -77 over 2. Okay, and I don't have a calculator on me, so I'm going to have to 55 times 10 is -550. -550 divided by 2 is, let's see, 2. I'm going to just do this real quick. 2, then 4, that's 1, 15. That's going to be 7, okay. Looks like it's got to be this guy, but let's just verify it. 14, drop the 1, that's 5. There we go. So, don't forget that it's negative, okay. But that is a -275, so the answer is B. Okay, so Dana is filling a 1.5 gallon watering can at a rate of 0.75 gallons per minute. What is the domain of the function that represents the volume of water in the can after X minutes? Okay? Okay, so she's filling it. Okay, so what this means then, all right, you've got to start at time 0. At time 0, and the max she can fill this up at is 1.5. Okay? All right? We just have to know how long did it take to get to here. Okay? So what we're going to do is we're going to take the 1.5 is going to be divided by how many gallons she can fit per minute. Okay? Because we want the x-axis to be minutes. So how long would it take for this guy to fill up? Well, if I'm doing this every minute, then in order to get to here, that is a total of 2. Okay, so you have to divide those two. We didn't have a lot of practice with this, but this is kind of a more common sense thing. We have our domain then. We are going from 0 minutes all the way to 2 minutes. Okay, and so 0 and 2 can't be this guy, can't be that guy, because that is the range. This is the range. But can I equal 0? Or do I not equal 0? Is there a time 0? Was there an amount in the can at time 0? And the answer is absolutely. Is there a time? Do I actually go up to 2 minutes, or do I go up to 2 minutes and then stop? Do I have like 1.999 minutes? The answer is no. You can go up to 2, set the timer, and then stop as soon as you include it. So the point is that you can include those. Okay? It took 2 minutes to fill up the can, and there we go. All right. So now, this one involved a parent transformation. We know that an absolute value is a V shape. And so what we want to do is we want to know when this guy is increasing. So we want to know when is the leg of this guy actually going up. Okay, where does he start at the vertex and then goes up? Well, we got to figure out what this guy looks like. And so, if you remember that if we have a negative sign in the front, that means that he flipped. Okay, if you remember your monster transformation assignment that was passed back to you, we flip it when we put a negative sign in front. Then, if it's on the inside, we're going to move this guy to the right. Okay, so he's going to go here. Okay, then he's going to flip. Or you could look at it, he flips upside down, and then he moves over to the right. Okay, so it would look like this. All right, now where is this guy increasing? He's increasing all the way from negative infinity, all the way from negative infinity, all the way up to 2, and then he stops. Then he starts to decrease. So we're looking from negative infinity to 2 is right there. Okay. All right, and then we'll do this last one for this video. Identify the translations of the U shape. Okay, you guys did an assignments on this. This is the shifting of the vertical. You also did a maze. Okay, what is this guy doing? This guy's moving to the right 5, okay, and then he's going down 4. Okay, so on the inside, it's the exact opposite of what you think. It's not going to the left. He's going to the right. But when you see parentheses next to the X, you're going to go, or the X inside the parentheses, he's going to go to the right, and then he's going to drop down 4. So down 4 are these two, and then we're going to go to the right 5. Okay?